Yes, we can hear you.
Very good, very good. So I want to welcome everyone who is following this proceeding online for this year's Oshwal College IT conference. The first time we are doing it
Yes, we can hear
online.
you.
We always hold very good, very good. So live. I want to welcome everyone who is following many other institutions for this year's Oshwal College IT conference. Now the main purpose of this first time conferences
Yes, we can hear you.
is to always equip our students with the new I want to welcome everyone technologies following many other just as an add-on for this year's Oshwal College IT conference. Now the purpose we are able to equip our students with more skills beyond what the syllabus is saying we cover. Therefore, today we are having just one of those conferences. I remember sometime this year, in the month of February, we had a similar conference where some taking us through ethical hacking. Previously, someone was taking us through artificial intelligence, and I believe our students have continued to gain these kind of skills. So today we have a conference which is centered around robotics. So we want to see, because you know, the whole topic of robots is taking over the world, and I believe it is the high time that as an institution we also start equipping our students on how to assemble robots in preparation for the future. We usually do not prepare for yesterday because yesterday is gone. So we normally prepare for the future. Now, IT is basically the future, and it is very dynamic. So the kind of programs and the kind of systems people are using today, they will have changed and evolved in a few years' time. And therefore, we believe that in a few years' time, we will be deep into using robots. Therefore, those who are here today, I'm sure you will gain immensely through today's presentations. This is just an eye-opener. We don't expect that by end of the session today you'll be able to assemble a robot per se, but we are just giving an overview of how it is done so that our students can know where they will start. With us in this conference today, we have the guest speakers. They come from a company known as Young Survey and Engineering Center. So they are going to give us more details of what they do, and even where they are located, and even how they do what they do, so that because they have been in this field of robotics for a while. We are also going to see some live demo of the kind of robots they have created, and the kind of robots you might be able to create in your future. So those of you who are still in the diploma, our BTech diploma program, it is to prepare you that as you move on to the degree, then you can take a project in the area of robotics and you create a robot that will be able to do 1, 2, 3. Those who are in the degree and maybe you are yet to do your project, like I know there are those who will be doing their project next year, like Kinawapa and the team. Then it means next year, as you select a project, then it's a new area we are bringing in. We have been creating, web systems, and all those kind of topics. But now in our collection, we are adding robotics. And therefore, it is a very, very important session that we are having today. Those of you who are in the degree and your final year, you have already selected your topic. I believe that moving forward, maybe in your masters and all that, you may want to venture into robotics, and therefore today's session can also be very important to you. Therefore, without taking more time, with us we have Dr. Wambugu Andia. She is the founder and the CEO of Young Survey Engineering Center or Engineer Center. She will take us through some, highlights of what they do. And then we have Mr. Derek Ngige. Derek is a certified robotics and coding trainer. And this year he was awarded the UN Person of the Year Award because he participated in creating or innovating a hospital ventilator. Those of you who had the President of Kenya talking about some young people who have come up with ventilators which can be assembled locally, then Derek is in that team. So you're in the right hands, and therefore I want to invite Dr. Wambugu just to take us through for some presentations.
Thank you. It's a pleasure to be at Oshwal College and to take us through the theme of this year, that is robotics and automation. And we come from Young Survey Center, and what we do is to explore science, engineering, and technology concepts. That's our main focus. And basically narrowed down into robotics, coding, and 3D printing. So our key focus is to place robotics, coding, 3D printing in the hands of the young generation, because we believe we are in the times where the way we used to do work has changed. And the generation that we are in, the young generation, they are living in the times where there is more of automation and less of human work. And this is where we come in to be able to equip the young generations to do robotics, coding, and 3D printing. And where does this fall in academia? It falls in integrated learning. Currently, we have the disciplines of science as a field on its own. We have technology as a field on its own. We have engineering as a field on its own, and mathematics as a field on its own. So with robotics and coding, we are saying that we are having integrated learning, what is commonly being referred to as STEM. It integrates all the concepts that are being learned in these specific disciplines as standalone or silos into an integrated forum, and is able to fit into the market. So that is where robotics and coding lies in terms of the learning. And better to that, we are living in the 21st century times, and they are the competencies that the employers or the entrepreneurs, the innovators, and the market is looking into. And one is creativity. You'll appreciate creativity is changing how we do things. Prototyping skills, or commonly known as programming. We have computation thinking, social cohesion, problem solving, communication skills, and critical thinking. These are the competencies that are required in the market in the times that we are living in. And this is what Young Survey seek to ensure that you work with, they are getting into these competencies, and once they get out of the education system, they are able to use the creativity that they have and to be able to logically think and find solutions to the global challenges that we are having. So what we mainly look at is what is the problem that is there and how do we address it. Basically, that is the learning that takes place. Where are we now, and how has the world moved? To start with, we had the first industrial revolution. And this is where water and steam power was used to mechanize production. Then we moved to the second industrial revolution, and there was use of electric power to create mass production. So electricity was mainly used to do production. Then came the third industrial revolution, and we saw increasing use of electronics and IT to automate production. And where are we now? we are in the fourth industrial revolution. And the fourth industrial revolution is a build-up on the third industrial revolution, where we are seeing now it's less of artificial intelligence, it's more of artificial intelligence being able to do the functions that humans were doing. So then how well are we equipped in the fourth industrial revolution? Some of the characteristics that we are seeing in the fourth industrial revolution is the fusions of technology that integrates physical, biology, and the digital space. So all these specific areas coming together to be able to perform the work. And like, for instance, the ventilator that we are talking about, the visual assistance that you are able to see if you log into most websites, you find a visual assistance that is there. Yes, it's a form of human, it's also IT, and it's also physical. That is what we are looking at. We are looking at the next opening in terms of tourism in space. That's the next frontier we are looking into. So how do we get to the space? We are now working in terms of looking into the electric cars. So that is where we are at. And actually there is a study done where it is saying that it will be more beneficial to countries for people to stay home than to keep moving, and robots are moving and delivering the materials and the items that we use. So we are seeing in terms of the velocity and scope and the impact with the systems, it's coming at a very high rate. And for instance, this webinar, we are able to continue working out of the face-to-face that we are used with. And this is a disruption into every industry. And whichever industry you want to think about, you'll see the fourth industrial revolution in terms of the integration of technologies from several spheres is causing a change. And for instance, the transport sector, and when Uber came into place, there was a lot of disruption into the industry, and there was a lot of resistance to change. But the truth is the industries are being disrupted. Like, for instance, printing industry is another one that is being looked at, because if you're able to work online, then it means less of printing. And what we are saying in the fourth industrial revolution, it's exponential rather than linear. That means it's coming and alive, and it changes how we do business. So that is where we are at. And some examples of the industrial revolutions that we are looking at, that is additive manufacturing. This is basically 3D printing, where you're printing from, you design the model that you want to print in a computer, in a card, and you are able to print. We are looking at autonomous robots. These are robots that are able to function with less of human interaction. We are seeing more of simulation, where before the product is tested into the market, there's a lot of background real testing whether it is working at the computer level before it leads to the market. So there is a lot of simulation in terms of the functionalities of the product that get into the market. A lot of artificial intelligence. These are intelligence machines that we are seeing currently, and Internet of Things. That is the connectivity of networks that we have. So basically, this is an overview of what fourth industrial revolution looks like. And this is the day that we are in. So the question is how well are we placed to be able to fit into the information society that we are at currently. Some facts for us is that yes, globally there is a challenge of employment. However, we are saying that they who are equipped in the STEM occupation, that industry, the rate of jobs grew by 2.4 million in terms of the availability of the jobs that were not filled. That this data is as of 2018. We are waiting for the current data to see how is the trend in terms of employment, and that tells you as we move forward there will be more skills needed to be able to operate the robots, to be able to code, to be able to provide solutions that they are less of human and more of robots, but that does not mean the humans are not required. It's only that the market space is being defined, that it is more required to be able to provide a solution, you code it and you bring it to the market. What that means is our preparedness towards the market is not the traditional way that you do things. It's to be able to align with the skills that are required for there to be jobs. And you'll find that the flip side of it, yes, this being the current need, the uptake of the STEM-related fields, like in the Commission of University, this is our current one. The statistics that demonstrate that only 25% have STEM-related courses, and also 78% of the students, they would tend not to pick the STEM-related subject. These are data that is currently showing, but it's also showing that this is the space that has opportunities for work. So to be able to align ourselves to take up the space where the work is happening and to be able to make a difference in that market space. Back to what we do at Young Survey Center, we have programs that are age targeted as early as 9. Why 9 years is because you appreciate the ECD, how it's structured. The cut of ECD is 8 years. That's early education. So from 9, the child has had the mental capacity to be able to interact with the chips that are used and the sensors that are used in that one. So as early as 9 to 12 years, you orient the children to robotics and coding, and what we call the beginners robotics and coding. Then we have the intermediate. These target the 13 to the 17 years. And in here we have advanced coding other than the beginners, and this is we call RC101. Then we move to RC102. This is the advanced robotics and coding, and this is near the market. So it's a solution that can be developed to hit the market space, and that goes to the 18 plus. And in there, the models that are done, the prototype, you are able to train on how does it look like physically, and that is using 3D printing. This you train on how to design a model that can be printed, and also you have a 3D printer and we demonstrate how does 3D printing work. So that's a session on its own. In brief, the BRC, these are the learning areas. There is an introduction to tools and software, then introduction to code. There is a lot of building and programming because we appreciate the mental development of the children at this stage. And by the 10th week, a child is able to identify a challenge in the society and provide a solution and build a code. So that is what takes place in the 9 to 12. The intermediate, that's RC101. These are slightly advanced, and we have introductions to tools. Then there is graphical stroke block programming that happens. There is introductions to sensors and actuators. There is remote control. Then the projects that are taken, they are done at 2 levels, at group and individual projects. And the culmination of that is debugging, to be able to test where is the error in this robotic. And by the time debugging is happening, there is the demonstration of understanding of the concept and intermediate robotics and coding. Finally, advanced robotics. This being near market, it's intense in terms of the learning that happens. There is basic programming concept. Then there is introduction to control structures. You have functions and modules. You have exceptions and files, data types, functional programming, object-oriented programming, regular expressions, and robotic project with Python. So this one is an intense program to prepare one to fit into the market, such that when looking for employment or when creating employment, there is the skill set that you're able to demonstrate that in the area of coding and robotics, I am well equipped to do that. 3D printing, this is what it entails. Introduction to 3D printing technology. 3D printing, that's CAD modeling. We have Stricer program. There is the use of the 3D printer, that is to actual print. Then there is the slicer setting. That's quality printing, print stick, extruder material, and project with 3D printing. So this is a module on its own that we normally offer. Our learning camp, we explore, we create, we communicate, and there is assessment. Generally, that is how we do all our programs. The learning resources, these we have the kitties, and I believe you'll have an opportunity to see that in this webinar on how this kitty looks like and how they function. And there is also now the coding platform. And from there, for continuous learning, we believe in continuous learning. We have clubs, can build club, those are the young ones. Then see there is iCode club, and the advanced one you have Digiplo lab. It's a lab because it's a platform to test your idea whether it can penetrate the market or it's a viable, it's a feasible project that can actually translate into a business. That's why it's a lab. And what are we to do next? We are to shift into actual demonstration of what we have been talking. So we are able to see how coding happens. And then we have an opportunity to see a robot that is functional. And at this point, I would want to welcome Derek to take us to that session.
All right, so Derek, you can start off.
Okay, thank you very much, Dr. Erin, for that opportunity and explaining to us what is robotic. And now start with a short video. And basically, I decided to pick on two areas in this webinar, and one.
So it makes quite a sharp turn and returns to a deviation. So it will follow through the loop until it's back, because it's trying to correct its routes. So this is actually a very tense case, which you have to get it right every time. So that is actually how it works. And with multi-threading, now you can now introduce how you look into having more sensors. And you can see it has gone all the way back to the command routes. So that is basically how we control it. You're using a light sensor and a camera to control your motors using electrical signals. Then you proceed to do the other demo. So this, as I've mentioned, we have multiple sensors. This is the IR sensor. We also have the gel sensor at this point. You can also have a dark sensor, so just in case it bumps into something, it will stop. So on this other point, you can have what we call, you can measure the distance. So if it comes in somewhere, maybe a block, it can stop. So because the distance between that object and the ground changes. So using this, the same brick, we are going to switch it off so that we are able to use it as a Bluetooth receiver so that we can control our other model, the robotic arm. So as it switches off, This is a caterpillar, and actually this is quite, and it is inspired by one of the tracks I saw on the road called Mahindra. And one of the basic things is these arms are what we call the 3DOF, or a 3 degree of freedom arm. But we are actually 3 degrees of freedom, which means it can turn into 3 ways. And usually, it's all normally controlled by, let's say, 3 motors. But with this design, you are only using 1 motor to control your whole arm from the opening, lifting up, and moving it down. So, I believe we are ready. I start the program. So, this we are using graphical programming, Bluetooth control, remote control. Okay, so we give some time so that they can. That is ready. So we are waiting for this to boot up. Okay. So I'm using this is the controller I'm using. So I'm using this, it's running the program also, and I'm using it to control the board. So that's the coordinates. I turn to the right, the left. And so that is the robotic arm. And as you can see, the good thing about this, and it's still early stage of development. As you can see, we have a camera set up We also have the camera, which is set up at this point. And also we have ultrasonic sensor at this point, and different models, a caterpillar way of running the model, which is very, very interesting. So that is basically about this tutorial and the innovation. So you can always do more, just have to be very creative and design, because we in the age of, as we have been told earlier, like Charlie, that this is the age of the fourth industrial revolution. We have to look at ways of developing our country, coming up with useful innovations and building things that matter. And we have to equip ourselves with skills that are important to us, and also that skills that will help us to grow our manufacturing capabilities and promoting manufacturing in our country and also in Kenya, in Africa. So we're looking forward to see transfer engineering and robotics and coding class, and we're very excited to learn much about this. Thank you very much.
All right. Thank you very much, Derek. I think we were able to see now the robot in action. Basically, that is what you create on the simulator, whether using the blocks or coding using Python. And then there is the kit that has the gadgets. So you follow the steps you've created on the simulator, and you are able to use those steps now to construct the robot or to do the robot. And you can, with the same with all the gadgets in the same kit, you're able to come up with as many kind of robots as you want. In fact, Derek and the team have created quite a number, including a drone. So it is a wide topic. We know Akash is doing his area on the health sector, where a robot can deliver things in an isolation room. I mean, someone else can have another idea of a robot that can do something else, another person can have an idea of a drone, another person can have an idea of something else, you know, including a robot that can be able to do PT, so that we see whether we can eliminate the need for housemates. So Joel, I think you can wrap up.
Thank you very much, Mr. Kamau. I want to